Sorry that these talks are a little bit out of order, but I'll try to be quick since I'm keeping you all from lunch. But I want to hark back to what Craig talked about, which is the science of the corona and how that impacts individual people and how we can bring that to the public. Craig showed you this picture of the solar eclipse. This is not exactly what you see with your naked eye. This has been highly processed to bring out all the detail and contrast. What you see with your naked eye is in some ways more awesome because you're there in the moment and you're seeing it with your eyes. And in some ways, of course, you don't see all these details. But what this highlights, what you're seeing here is the sun's magnetic field. And the bright stuff that you see is hot plasma. It's ionized gas that is acting like iron filings in the magnetic field. It's tracing out that magnetic field. We can't see this magnetic field with our eyes. We can't even measure it with our instruments, but we can see the traces of that field through this plasma. And eclipses give us that insight that we don't normally get from space. As Craig said, you have to put telescopes in space that don't give you the same quality you get from them. And we're still trying to answer lots of questions like why corona has this kind of structure. What keeps it in that kind of shape? Why is the corona so much hotter than the surface underneath, which you haven't necessarily heard about previously in these talks, but it's one of the mysteries of the corona that we're trying to solve. So there are changes that happen in the corona on minutes or hours or days, but there are very important things that you can't see from space and that you may not be able to see from the ground. And that you can see during total solar eclipses. But part of the problem is the shadow moves really fast. In fact, at its slowest, the shadow is usually moving at around 1,500 miles per hour, right? So it's faster than any commercial jet. It's not quite as fast as all supersonic jets, but it's still very, very fast. And so when you're at one place on the ground, you get a few minutes, right? And it's hard to see things changing in the corona over just a few minutes, but if you could somehow watch for an hour or an hour and a half, then you can start to see things actually changing and happening in the corona. And you can't do that from a single site. And it's very hard to chase the shadow because it moves so quickly. But if you have the shadow chase you, then you can do that, right? And then if you put a lot of stations along the path, then you can look at each one as the shadow passes over them. And if you play your cards right and you make the observations correctly, you can put them all together as if they were one single instrument and then get a movie of the corona for an hour. And in fact, this was pioneered back in the 2017 eclipse by Matt Penn, Bob Baer, and company in CATE 2017, where the eclipse passed over the entire United States. Every individual site had only about somewhere between 2 minutes and 2.5 minutes. And so they had 68 different teams spread out across the United States with 300 citizen community volunteers. They don't have to be citizens, but citizens of the world, community volunteers that ran telescopes. They were trained on how to use them. All of the telescopes were the same. They were given that equipment, and they put all of that together to make an observation of corona. I do want to point out that they do have another project coming up called DEB. If you have questions about that, talk to Harvey. Since Bob is not here, the website is right there. They're revamping their CATE 2017 initiative with new instruments, trying to make it easier, less expensive, more accessible to people, and try to address very similar science. In our case, we're doing a different offshoot of CATE 2017, and we're going to start making images of the polarized solar corona. So just to make sure everybody knows about polarization, of course, light is a wave, and it waves in a particular direction. And if you have polarized sunglasses, you've seen this in action, because when you wear these polarized sunglasses, they cut out reflections from water or water on the roadway. And that's because that light, when it reflects, is in a particular polarization. It's in a particular direction that gets removed by your sunglasses. And light from the corona is also polarized. And this is an image that we took with the CATE equipment in Australia, in Exmouth, just a few months ago. And the different colors that you can see here are different angles of polarization. So here, here's, you can even see it better. Here, the different colors actually represent all of the different angles of polarization. You can see that changes as you look in different areas of the corona. And if you look carefully, this can help you understand what are the various processes happening in the corona. Now, just to give you a sense of scale, how does this relate to Punch? Punch doesn't see anywhere near this far down. So right now you're looking at the sun plus about maybe 3 suns worth onto the edge. We have instruments in space that can look out to about 6 suns worths. In fact, they can actually go out to about 32. But Punch, what we're going to be observing is that inner bit. And then this is the inside instrument of Punch is going to see this much. The near field imager is going to observe, or narrow field imager observe this much. And in context, this is, how big that is. So this gives you that same sense of scale Craig was trying to give in a different way. Why is this important? Because, Punch is going to be looking at how space is filled with the solar corona and the solar wind. But it's hard to understand how that happens if you can't see the origins of the sun. And so solar eclipses tie what Punch will see to how that was born at the surface of the sun. And even though the 2024 eclipse will be before Punch launches, Punch will be up during future solar eclipses that we can merge together. So we are going to be running this experiment. We're going to be recruiting 35 or more teams that live along the 3,000 communities that are along the path. And one of our goals is to reach into traditionally underrepresented and overlooked communities and try and make sure that we can bring them into the love of science and help give them the opportunities to interact in ways that they may not normally have. And our educational team is also partnering with the Rising Voices Network and other community organizations to partner. But one of the ways that we're doing this, we know that we, at the scientist level, we don't have a lot of insight into what local communities are like. We don't necessarily have a lot of insight into how local communities interact with the sun, with science, with scientists. And so we have this sort of hierarchical structure that help us provide that inreach in a more intelligent fashion than we could do by ourselves. So we have these regional coordinators. Our Southwest coordinators are at Rice University. Our Midwest are at Indiana University, and Northeast is the University of Maine. And once we get our major funding package from NSF, we're going to begin recruiting, hopefully in just a month or so later this summer, for our state coordinators. And those state coordinators will have a better understanding of what their local communities are like, and they will help us recruit local teams. Each state coordinator will be responsible for about 3, 4, 5 local teams. And so that spreads the work out amongst all of the folks and also makes sure that everybody has the insight on how best to interact with those local communities and what this science might mean to them. And just like with CATE 2017, just like with the DEB initiative, CATE 2024 wants to deposit equipment into those communities so that they can be a resource in the future. We want to deposit educational curricula so that those telescopes will be useful, not just for this eclipse and not even just for sun watching, but for future science. And so if you're interested, please shoot us an email. We're also on Twitter, behind Craig's knee. If you're interested in DEB, please talk to Harvey, and hopefully we'll have a great solar eclipse. Thank you.